Hi, this is lesson 325, applying the tangent ratio. So now that we have an idea of how to set up our problems for the tangent ratio, let's see how we could use this in a real life situation. All right, so we're just going to go over one problem, and this one involves the Statue of Liberty. So if you've been to New York, most likely you've possibly seen the Statue of Liberty, um, or maybe you've seen it on TV or read about it in your history class. So in this situation, we have Lindy who gets nosebleeds whenever she is more than 300 feet above the ground. All right, so 300 feet above ground. During a class field trip, her teacher asks if she wants to climb to the top of the Statue of Liberty. Since she does not want to get a nosebleed, she decides to take some measurements to figure out the height of the torch of the statue. All right, so the torch would be up at the top. And so she wants to figure out how high this is. She finds a spot directly under the torch and then measures 42 feet away and determines that the angle up to the torch is 82 degrees. All right, and her eye height, her eyes are 5 feet. Oops, forgot to put that in there. So her eyes are, let me include this, 5 feet above ground. All right. So they've given us some key measurements. What we're going to look at is, should she climb to the top or will she get a nosebleed? So let's make sure on this one for sure you draw a diagram. It's a common test question for me to ask you to draw a diagram that represents the situation. That helps with just knowing you could label a diagram tells me a lot about what you know. It's not always about setting up an equation. So we're going to take this information and redraw this situation. So for now, I'm just going to draw it on this photo that we have here. So from the torch down, she measures 42 feet away, and she looks up at the torch and she realizes, maybe using some tools, there's actually a tool on your phone that'll tell you an angle, and that was 82 degrees. So that angle is 82 degrees. So if you notice, we have a right triangle, where we know an angle and we know a side. This is exactly what we've been preparing for with our tangent ratio. So our goal is to figure out the height of this. So there is one extra piece of information they give us, her eye height. Why do they give us her eye height? Well, if you think about it, when you look up, you look up through your eyes, right? Not the top of your head. Although in this situation, it probably is not going to make much of a difference. But since the numbers are probably going to be large enough where it doesn't matter, but it will have an impact, not necessarily on the angle, but the height. So when she's looking, she's actually 5 feet above the ground. Her eyes are 5 feet above the ground. So there's this little portion that we need to take into consideration. All right, so let's look at a drawing of this. Yeah, this is a drawing. This is not a photo. I know it looks just like the photo, but this is, I actually drew this. So I've drawn in the measurements. So this is pretty much what I would expect you to have on your paper. It should represent the situation. In this case, just by looking at it, you know it has something to do with the Statue of Liberty or some green monster on top of a pedestal. So I have the measurements given to us. So there's the 42 feet away, and then there's the 82-degree angle. And in the 5 feet, you'll notice I've drawn this triangle above the ground. So if you drew the triangle to the ground, that would not be correct, right? Because they intentionally told us that her eyes were 5 feet above ground. So when you draw this, be careful. There has to be this gap. There has to be the gap between her eyes, her eyesight, and the ground. The reason is we need to take into consideration is 5 feet. So we want the total height, but if we're only going to be able to calculate this portion of it, we're going to have to add 5 extra feet when we get our final answer. All right, so let me write that out in equations. Hopefully you're drawing that out. The work doesn't really mean much unless you have a picture to go along with it. So since this is a right triangle, right, so since we have a right triangle in here, let's set up our problem like we normally would. Now I'm going to add some variables to this situation. Let's call this, I'm going to call this y, just because it's the rise. But keep in mind what we're looking for is the height. So the actual height is going to equal to whatever y is plus an extra 5 feet. So if we can figure out what y is, then that'll help us figure out the height. So let's start with setting up an equation. So I'm going to start with tangent of, we have 82 degrees is equal to, well, this is going to be the y, right? Just like we normally do. Angle, line across. This is going to be y on top, and then we're going to do the 42 on the bottom. All right, so then we're going to solve this. I'm going to put this over 1 so that we have it set up like we normally do. And so let's cross multiply that. And we're left with y equals to 42 times tan of 82. All right, so now technically we know our y value. All we need to know is our height. So let me rewrite this as the height equals to 42 times tangent of 82 plus 5. All right, so technically this would be our answer. Now it doesn't really mean much to us unless we put it into a calculator. So then at that point, you would just type that in. You could probably type it in exactly how it is. And so that would give us, so let me zoom into this. So this portion is just 200 and it's about 299 plus the other 5, which is going to give us 304 feet. All right, so our height is 304 feet. So then the question is, should she climb to the top or will she get a nosebleed? All right, and so I'll let you answer that question at the end of the video. So we have, this is what your work should look like. You set up an equation, you solve it. In this case, there was a little bit extra 5 feet we needed to add. And so we found the height, but we still need to answer the question, which was, should she climb to the top or will she get a nosebleed? All right, and so justify your conclusion. So that's going to be your question to answer. So hopefully you have a good answer to that.